Yes, I got it. How did you do all that?
All right, pick up your colored pen. Today we start a new chapter, and we're starting fresh with an FCAT question that actually comes directly from an old FCAT test. And then I actually added on a higher level question to it. So let's see how we did with the basics, and then we'll go to the higher level work. What was the mean temperature for the week? Got 1, 2, 3, 4, 5, 6, 7, 8. We got a whole bunch of common people. Brianna, Talia, Aaron. What'd you get? Okay. The mean temperature for the week is -5 degrees. On how many days was the actual temperature lower than the mean temperature? How many days? Ethan, India, Yasmin?
2.
2. 5. 2. Okay, so we have some disagreement. Deandra? 3. We got a lot of disagreements. Eliana? 2. So it seems to be overwhelming support for 2. The correct answer is 2. Which days? Which days, China? Tuesday and Friday were lower than the mean temperature?
Oh, sorry.
It is Monday, which is -11. That's smaller than that. And Thursday is -13. That's smaller than that. So the 2 days were Monday and Thursday. So part A was really just a basic concept that you were supposed to have learned last year that I'm reviewing. Part B was just interpreting. Just putting in a tiny bit of thought and looking at the numbers, and you had to understand what smaller means, or lower. Now part C is where we use algebra that you've been learning this year. What would the temperature have to be on Saturday for the mean temperature to be -4? 1, 2, 3, 4, 5, 6 people. Same 6 people. We'll start with Chris, Nicole, Aaron, Ethan, and then we're coming over here. Okay, well I can appreciate that, but you should have done something. So I'll come back to you after I get to the other 3 people. Nicole? Okay, but again, it wasn't an optional question. At no point did I see your hand go up for assistance, nor did I hear you discussing it with your classmates like there was a bunch of people over here. Okay, I lost my order. Was it Aaron? And then some? Go ahead. 1 degree, okay. You get the same thing. What did you get? You got 1 degree?
Yep.
Taylor? You got 1. 5. 5. China? 1. Shannon? 1. The correct answer is 1 degree. So, we're going to spend our time on part C because you were supposed to know everything about part A and B already. So, part C is asking you to take the situation and add to it. What I've basically said is, if I added a new column right here and called it Saturday, what number would have to go here so that the average or the mean came out to -4? So the temperature has to be 1 degree. There's only one possible answer. Question is, where does that come from? So Ethan, you had done it incorrectly first, and then you discovered a mistake, and that was really a key mistake that most of my students make. But let's get to the thought process. What was the total after you add up the first 5, Ethan?
Oh.
No, the total.
-25.
Right. When you add up these 5 numbers, you get -25. Oops. -25. And then to find the average or the mean, -5, what did we do with that number? What did we do with that number? Taylor? Divide by 5. Why do we divide by 5? Because there's five numbers. Very good. So we do this, and that gets us the -5. But now I'm asking you to add something to here. I'm asking you to add some number here. Because this is the total for the first 5 days. But now I'm saying let's add on one more number. And then we want the results to equal -4. But there was one other detail that you had to be aware of. What was the other detail? India? That was it. Very good. You have to change the 5 to a 6 because now it went from 5 days to 6 because we added on a whole nother day. So now you're saying, okay, what number must go here to add to -25, then divide by 6 so it comes out to -24. Here's another way to look at it. Let me take this away. I'm going to take this away, hopefully, for a moment. What number would have to go here so that this became -4? What number has to go right here so that when it's divided by 6, we get -4? Got a bunch of people who know. Deandra? Yeah, this has to be a -24. So what we need to do is figure out how do we get from this to -24. And so the only possible way to do that is to replace the question mark with a 1. When you replace the question mark with a 1, this turns into a -24, and then when we divide it by 6, we get -4. My students who all said the answer of 5, you all made the same one mistake. What was the mistake you made? You didn't change the 5 to a 6. And that was very common with all of my classes. And that's okay. You did most of the hard work. You just got to pay attention to that little detail. Okay? Comments, questions on today's warm-up? Comments, questions? Okay, draw a line across your paper. So today we're going to introduce the idea of ratios and then talk about weights and unit rates. You were introduced to the ideas last year, but we're going to expand on them quite a bit. And these are actually building blocks for a more complex and important idea called proportions. So today, as the whole year has been, is constantly building on what we learned before. So first we want to establish some ways of communicating with each other. We're going to be using the terms ratio, rate, unit rate a lot today and beyond. A ratio is when you're comparing two quantities with division. And you're going to see in a couple of minutes how we write that. Equivalent ratios. Two ratios, or more than two ratios, that have the same value. So I want to talk about value for a moment. And I've had this conversation with this group before. And I always use money as my example. So, can I have some volunteers give me a way to construct a dollar? Using coins or bills or whatever you think. Christian? 4 quarters. So 4 quarters has the value of $1. So 4 little coins, 4 silver coins, if I hold them in my hand, that has a value of $1. So that's one way. Taylor? 100 pennies. So 100 copper little coins, 100 of them, that would be a whole pile of coins, has the same value as the 4 quarters. Do they look the same? No, they look totally different, right? One's 4 silver coins, The other one, if you can picture it in your mind, is 100, a stack or a pile of 100 copper pennies. Looks totally different, but has the same value. Any other ways to do it? Kayla? 5 dimes and 20 nickels? That's going to be more than $1. So why don't you think it through, and then I'll call on you again in a moment. Amaya?
3/4
That's a little less than $1. 3/4.
Oh, 2 dimes and a nickel.
Right. 3/4, 2 dimes, and a nickel. But listen, this is important because there are tons and tons of different ways to construct a dollar using dollar bills and coins. And so she just illustrated that there's more creative ways. So that's 3/4, 2 dimes, and a nickel. So we have 6 coins, right? 6 coins. 3 of them are larger coins, 2 of them are tiny little coins, and 1 of them is kind of a medium-sized coin. Looks totally different than the 4/4, and looks totally different than the 100 pennies. But it has the same value. And that's really the part to understand, is that the same value can look totally different. Okay? Guys? 10 dimes. Again, looks totally different. Ethan? 2 50-cent pieces. 2 coins can have the same value as 4 coins, depending on what coin it is. Alex? 20 nickels. Very good. So again, a pile of 20 coins has the same value as a pile of 10 coins, depending on what type of coin it is. You can put your hands down, we'll get some more a little bit later. But the idea is this. When you talk about the word equivalent, value, it can look totally different, but whether or not it has the same value is the key point. So you're going to see ratios that look different, but have the same value. And that's an important skill for today. From there, we're going to build to the idea of a rate. We're going to build to the idea of a rate. A rate is a type of ratio. The difference between a rate and a ratio is that a rate uses different units of measurement. And this lesson and beyond this lesson, you're going to start seeing a lot of real-world experiences that really are much more readily available to you with this type of content than what we've done so far this year. And then another skill that we're going to work on today is the idea of a unit rate. And this is used widely throughout our society in a lot of different ways. It's used every day. You actually see them every day. Does anyone know what MPG stands for? MPG. And you might not. It's not a big deal, but when you hear it, I bet you will realize that you did. PR? Is that what were you going to say? Yeah, MPG stands for miles per gallon. That is a unit rate that we use every day. You may not, because you don't drive yet, but your families do. And you actually see it every day when you drive past gas stations, when you see car commercials on TV. You're seeing unit rates expressed all the time. And a unit rate is a rate when the denominator is 1. And so you're going to learn today how to turn a rate into a unit rate. Okay? Any questions so far? Good. So let's go back to the idea of a ratio and let's talk about what they look like and how we write them. You can write ratios 3 different ways. You can write it with the first number and the second number with the word 2 in between. A to B. You can replace the word 2 with a colon, and this is still read A to B. It just looks a little bit different. And that's why we just had the conversation about value and money, because it looks different, but it's the same value. And then a very common way that we see ratios in our math class is this way. That's a fraction, but it is also a ratio. And these are all read the same way. They are all read the ratio of A to B, or usually we'll just say A to B. Here is something that is going to be established as a rule right now and is going to continue in my class for the rest of the year and every math class you ever participate in for the rest of your life. You always write ratios in simplest form. It's not a question you ask the teacher. It's not something you decide to do. You just do it. And it's already happened this year a bunch of times to me. I said, hey, Mr. Gallagher, should I write this in simplest form? And then I just give the person a quizzical look, and then I ignore them and turn around and walk away. Because they're supposed to know that you always write the ratio in simplest form no matter what. Don't ask me, just do it. The problem is if you don't do it, then it's wrong. Ratios are always written in simplest form, and you're going to learn how to do that today as well. Questions so far? So we got 3 major goals with lots of intermediate goals in between. Okay? So, we're going to jump right in with our first goal, writing ratios. So write example 1. Read this part of the text. You don't have to copy this part. But then you have to copy part A and write that down. So take 30 seconds to read and 15 seconds to write part A. So, as I said, one of our goals today is to be able to write a ratio when asked. And you write a ratio based on information from the text of the question. So I'm going to reread it. You already read it, but I want to make sure we're all on the same page. In a recent baseball season, the Anaheim Angels played 81 home games. That's actually true for all baseball teams. They all played 81 home games. Anaheim won 54 of those games and lost 27. Write each ratio in 3 ways. We're not worried about part B yet. We're only focused on part A. The number of losses to the number of wins. So what we want to do is look in the text of the question and find where it gives us the number of losses, or we might have to actually do some calculation to find it. But let's see. What are the number of losses that's outlined in the text of the question? Andrew? 27. It says they lost 27. So we're going to write down 27. And we're going to start out with the simplest way to write a ratio. We're going to put the word 2 in between. 27, 2, and now we need the number of wins. What was the number of wins? Justin? 54. Do you agree with that? Yeah, it's 54. It says it right there. They won 54 games. So the ratio is 27 to 54. But now, and here's the skill that I'm kind of mixing into the lesson, is that we have to put that in simplest form. And what that means is we have to look at the 2 numbers, the 27 and the 54, and decide whether or not they are both divisible by the same number. So you have to look at the 27 and the 54. Here's the good news. If you did your job at the first day of school in my class, then this is actually not hard for you. Because those divisibility rules that you memorized, or were supposed to have memorized, they're going to come into play now and for the rest of the year. So, can someone give me a number that 27 and 54 are both divisible by? China? They are both divisible by 9. That is correct. Justin? You were going to say 9. I apologize. Amaya? They are both divisible by 3. So they are both divisible by 9 and they are both divisible by 3. Are they both divisible by anything else? They are actually both divisible by 27 as well, And there was no divisibility rule for that. But she just happened to realize that they're both divisible by 27. So here's the thing. We have three choices. We have to pick which number we're going to divide both by. You always use the biggest number that you can find. So we are going to divide the 27 and the 54 by the biggest number that they have in common, and that was what Amaya said, which was 27. So we're going to divide by 27 and divide by 27. And that is what will put the ratio in simplest form for us. So what is 27 divided by 27? 27 divided by 27. Aaron? 1. So 27 divided by 27 is 1. And what's 54 divided by 27? Aaron? 2. So the ratio in simplest form is 1 to 2. And we are asked to write the ratio in 3 ways. That was one way. The second and third way are easy. It's just replacing the word 2 with something else. Yeah, it's the colon that you are either have learned about or will learn about in language arts. It's being used in a different way here in the math classroom. That's 1 to 2. And then another common way to write a ratio is as a fraction, 1 to 2. They are all read the same way and they all have the same meaning. They look different, same value. Any comments or questions on how we did part A? So there's a lot wrapped up into that one question. All right, part B. We want to write the ratio in 3 ways, the number of losses to the number of gains. So what's the number of losses? Going back to the text of the question. Christian? Number of losses is 27. We used that in the first example. But what's the number of gains this time? Number of gains. Alex? 81. It says it in a different sentence. So now we have the ratio 27 to 81. But now we need to decide if that is simplest form. Does the 27 and the 81 have any numbers, any factors in common? Aliana? 27. Any others? Yasmin? 9 again. Any others? China? Yeah, 3 as well. So they're actually both divisible by the same numbers that the other ones were divisible by. So which number should we divide by to make our lives very easy? India? Divide by the biggest number you can find. Divide by 27. So divide by 27, divide by 27. We already know what this will become. That's a 1. What's 81 divided by 27? Ethan? It's 3. So we have the ratio in simplest form, 1 to 3. And now write it the other 2 ways, which just means replace the word 2 with, as Justin said, the colon, 1 to 3, or the fraction bar, 1 to 3. Does anyone have any comments or questions on how we wrote these ratios, how we put them in simplest form, anything at all?
So, like, when we do this, we have to, like, when we put them in simplest form, we have to write all.
Yes, if you're asked to write the ratio 3 ways, you put all 3 ways in simplest form. The easiest thing to do is to pick one of them, put it in simplest form, and then just copy it into the other 2 ways. Okay? Good. Excellent question. Other comments or questions? So that's the first goal of the day. Let's see if you've digested the first goal. Checkpoint number 1. You are on your own for 2 minutes. Remember, checkpoints you do not have to copy. You just find the answers. 2 minutes, 2 questions. All right. Now, you were asked to write each ratio 3 ways. They're all read the same way, so you're just going to say it one time. But let's see how we did. What's the ratio of the number of wins to the number of losses? We'll start with Justin and then Brianna. Justin, what'd you get? Okay. So you two agree, Taylor? So we got 3 people who agree, and that is outstanding because the ratio is 5 to 3, and here are the 3 different ways of writing it. You should have written it all 3 ways. Outstanding. Part B, what's the ratio of the number of wins to the total number of matches? Start with Christian, Kiara, and then we'll go to Kayla in the back. Christian.
5 to 8.
Okay. Okay. Okay, so we have some disagreement. Anyone want to chime in with one of those and kind of even things out? Shannon and then Amaya? You seem to have more support for 5 to 8. Seem to be overwhelming support for 5 to 8. And it is 5 to 8. And that is the 3 different ways of writing the ratios. Now I must tell you before I open up the floor for questions that I was very impressed with Part A and how people did as I walked around. But that was actually much trickier than the original ones that we did together. What was tricky about Part A? Go ahead, Justin.
They didn't tell you the number of losses.
That's right.
They just told you how many games you worked and how many wins.
So how'd you find the number of losses?
You had to subtract the number of games. You had to subtract the number of games by the games won.
Very good.
It came out to
Good. And the number was?
9.
9. Excellent. Outstanding, and that was a great explanation as well. You had to subtract these 2 numbers to get the fact that they lost 9 of the matches. And then you can form your ratio from there. Are there any comments or questions? Kiara, I know you had made a small mistake. Do you realize your mistake now? You did everything right. You just divided. Any other comments or questions? Good. So that's goal number 1. Give me a thumbs up if you got both of them correct. Thumbs up if you got both of them correct. Good. Put your thumbs down. No comments or questions? Okay. Now, we want to be able to take ratios and either compare them with each other or put them in an order. So, example 2, if I give you several different ratios and I ask you to put them in order from least to greatest, what can we do to accomplish that? Believe it or not, you actually already have the skills that you need to do it. It's just a matter of adding your skill to the new context, to the new type of question. Of the 3 different ways of writing the ratio, with the colon, with the word, or with the fraction bar, which one's the most familiar to you? Which one's the most familiar to you, Benjamin? Fraction. Which one's the most familiar to you, Benny? Fraction? Yeah, that would have been my guess right off the top, that most people would say the fraction. Guess what? It is the most familiar to us because it's what we see the most and what we've used the most. So we're going to continue using that to help ourselves. We can rewrite 5 to 11 like this. We can rewrite 13 to 23 like this. Oh, I'm sorry. Thank you. Don't know why I did that. 5 to 11 is what I said. 5 to 11. Thank you for correcting me. And 3 to 7 is already written like a fraction. Now, I have done my darndest to help you become an expert at working with fractions to some degree. So, what do we do every day on these yellow slips? And I'm going to point to the one I have up here. What do we do every day after we write that ratio right there? What do we do? 1, 2, 3, 4, 5. 1/3 of my class knows what to do and nobody else knows what to do. You guys just rely on your classmates to help you. Brianna? Divide the top by the bottom. And what does that get us? That was beautifully said. And so The benefit of decimals is that they're easy to compare. Ratios and fractions are difficult to compare because when the denominators are different, we can't compare them. So if we use that skill that we already have, then we will convert the numbers to a decimal, and then it's easy to compare. So everyone pick up your calculator, and we're going to do this together. 5 to 7 is the same thing as 5 over 7. 5 over 11, thank you. 5 divided by 11. And push the equal sign. It's not optional, so if you don't have your calculator handy, then you should be doing it by hand. So you end up with this. Now, here's another little skill that we're working with on top of all the new skills, rounding. Now, when we're going to compare a bunch of decimals, we don't know how many decimal places we need because we don't know what we're going to need to compare. A safe place to round to is this third place value, the thousandths. So let's write down the number. We're going to write 4 places. So it's 0.4545. Now let's read this poem that I have asked you to copy down and memorize. Underline the digit. Look next door. So hold on. Underline the digit. Look next door. So here is next door. 5 or greater, add 1 more. So what will 0.4545 turn into? 0.4545, what will it turn into? Aaron? Yeah, it will be 0.455. And that is rounded to the nearest thousandth. Now we need our calculator again. We're going to do 13 to 23. And then we're going to do the same thing. 13 divided by 23. Push the equal sign. So we get this mess. But we're going to write down 4 digits. So we write down 0.5652. Underline the digit. Look next door. 5 or greater, add 1 more. So what will 0.5652 turn into? Christian? It's going to stay the same, except we're going to get rid of that last place value, 0.565. Any comments or questions? And let's do the last number, 3 to 7. 3 divided by 7. Push the equal sign, and you get this mess. But it's not really a mess. It's just 0.4285. Underline the digit. Look next door. 5 or greater, add 1 more. What is this number going to turn into? What's this going to turn into? Ethan?
It's to 0.429.
0.429. Now we can easily put these in order from least to greatest. And we're going to write them as their original form. We're going to write them as their, well actually their original form is up here. We're going to write them in their original form, but we're going to know which one's smallest based on this form here. So which of these is the smallest? Which one's the smallest? Tony, which one do you think is the smallest? 3 to 7. Amaya, what do you think?
37.
Yeah, 3 to 7 is the smallest. It was originally written as a fraction, so we're going to write it as 3 to 7. What's the next smallest? Christian? 5 to 11, because this also has 0.4 but 0.45, and it was originally 5:11, so we'll write it like that. And then there's only one ratio left, 13 to 23. And now we have written the ratios in order from least to greatest. Comments or questions on how we did that process? Now it looks like a lot was done here, but I went slowly and I did it step by step. As you get better at this, you should be jumping from here to here. You shouldn't have to rewrite this like this and then do this and then do this. You should be able to jump from here right to there and then be able to compare. That's what you should be able to do. China? Well, when I give you the answer key is going to be like this. So if you write your answers like this, you probably won't know your... Oh, just like this? That's fine. That's fine. Okay? Good. All right, so that was goal number 2. Let's see how well we've digested that. You've got 2 of them. 2 sets of ratios you need to put in order. This takes a little bit more time, so you got 3 minutes. That's 1.5 minutes per question. Still see quite a few people working, so take another minute. It's okay. As soon as you finish, it's just a minute. I'm asking you to be patient. Alright, now I think we are ready. So what is the order for part A? What's the order? Start with Kiara, Nicole, and then Christian.
5 to 12, 3 to 5, and 8 to 11.
Okay, what did you put, Nicole?
5 to 12, 3 to 5, and 8.
Yeah, you were doing fine. What's wrong? You said it wonderfully. Why'd you stop? Oh, I missed the last part then. I apologize. So it sounded like it was the same. Go ahead. Say it one more time.
5
Okay, I have no idea what's happening. I feel like I just entered some sort of time portal or something. Taylor? Okay, so you disagree with the order that Kiara had presented, Yasmin?
5 to 12, 3 to 5, 8 to 11.
Okay, so you agree with Kiara, so we do have some disagreement. China?
5 to 12, 3 to 5, 8 to 11.
Okay, 5 to 12. 3 to 5, 8 to 11. That is the correct order from least to greatest. 5 to 12, the decimal form is a smaller number than 3 to 5. What about part B? Part B was a little bit harder. Part B, we will start with India, and then Deandra, and then Alex.
5 to 11, 18 to 37, and 7 to 12.
Okay. What was the first one?
5 to 11.
Okay, and then say it one last time.
5 to 11, 18 to 37, 7 to 12.
And that is correct. Comments or questions on either of these? So Christian, what was the hiccup? Like, what was the all of a sudden you didn't understand? You were just
Oh, because I didn't put 5 to 12, I put 5 to 2. That's it.
oh, so you just wrote the wrong number. Oh, okay, that's not a big deal. I didn't understand what was happening. Okay. Comments, questions on either of these? Give me a thumbs up if you got both of them correct. So not that many, well, no, I take it back, about half the class, put your thumbs down. So what was the issue? Where did we go wrong? Ethan? Okay. Well, first of all, 3 to 5 you should actually know off the top of your head. That's one of my decimals that you should have memorized. So 3 to 5 we don't even need a calculator for. You should know that that's 0.6. So then 5 to 12 you can see is smaller than that. And then 8 to 11 is bigger than that. So if you had done your job from the beginning of the year and memorized all of these, or just know them, then that would have helped you. Okay? So, 2 goals down, last goal, and the most complex, although not too terribly difficult. So, now we want to be able to take the idea and apply it to the concept of a rate, and then use that information. So, on the first day of a family vacation, you and your family drive 392 miles. The amount of gasoline used is 16 gallons. What is the average mileage per gallon of gasoline? In the real world, we use the word per a lot to refer to a ratio or a rate. And so when you see mileage per gallon, that's a unit, that's a unit rate that describes the number of miles you can travel on 1 gallon of gasoline. This is incredibly important in our world at this point. You guys are not ready to buy cars, but you're only about 3-4 years away of driving. So this is actually information that you need to be very aware of. I bought my car, the car that I drive. The biggest reason I bought the car was because its mileage per gallon was so good. So you may dream of driving a Hummer 3, which would be great, except for the fact that it gets like 10 miles per gallon. My car gets about 30 miles per gallon. So when a Hummer 3 is finished driving all the gas in its tank, I'm going to be driving for 3 times that amount of time. So if they finish the trip and they run out of gas in 1 day, I'll be traveling for 3 days. So the problem is that gasoline costs money. Gasoline right now costs about $3.50 for 1 gallon. So if you're driving a Hummer 3 and I'm driving a very fuel-efficient car, I'm going to be spending a ton less money than you. You're going to be dropping money on gasoline so frequently and so much that you're not going to be able to afford the car anymore. So this is something incredibly important. So how is it figured out? So here's what we do. When we first start out, we write the rate by taking the first number. This means over, or the word to, the second number. So the miles is 392. So 392. And when you're writing a rate, you use the units of measurement with it. 392 miles. Over the second quantity, which is the gallons of gasoline, 16 gallons. We have just written a rate. 392 miles in 16 gallons. So you know that next time you fill up the gas tank, if you have 16 gallons of gas, you know that you can travel 392 miles. But that's not very useful information because then you only know how far you can go when you have 16 gallons. It would be much more efficient if you would know how far you go on 1 gallon of gas. So that's where a unit rate comes into play. And that's what your last skill of the day is. You want to learn how to convert this rate into a unit rate. And do not write this down. You're going to pause your pencil for a moment. So, the way you convert this to a unit rate is we want the denominator to be equal to 1. So we want this to turn into some number of miles over 1 gallon. That's what we want it to turn into. How do I get the 16 to turn into a 1? How can I get the 16 to turn into a 1? You can't use magic. You can't just take away the 6 and make it a 1. You have to do something that makes sense. Dalia? That's exactly right. Divide the 16 by 16, divide by 16, and then that turns into a 1. Now if you do that to the bottom, then you also have to do that to the top. So you divide the 16 on top, and then you get the number up here. But there's a shortcut for this, and you already know the shortcut. You don't have to divide the top and the bottom by 16, because you always know that you're going to divide the top by the bottom number. So that's all you have to do is divide the top by the bottom number. So let me back up for a second. You don't have to write this, you just have to know that you're going to divide the top by the bottom. 392 divided by 16. And so what do we get when we do that division? Justin? I'm sorry, I thought because you were sitting there that you had already done it. I'll come back to you. Tony? 24.5. DeAndre, did you get the same thing? Yeah, you get 24.5. And so what that means is that we now know that we can travel 24.5 miles every gallon of gasoline. And that is a unit rate. And very often, companies in car commercials will not write it like that because most humans are afraid of fractions. So they don't write it like that, and that's where the MPG comes into play. In a car commercial, this will say 24.5 MPG. And that is a unit rate. That's a very useful piece of information. So that's how you construct a unit rate. Now we want to learn how we use the unit rate. So I'm going to go to a different example. And now we're going to take the idea and use it. You do not have to write the text of the question, but you do need the table of information here. So make sure you copy the table of information. There is a concept in our society that when you go to a big box store like Walmart or one of the club stores like Sam's Club or Costco, that if you buy a larger quantity of something, that it's cheaper. That's why you and your families go to these places, because you're trying to save money. So, but here's the thing. That is usually true, but it is not always true. It's usually true, but it's not always true. So if you go to Costco and buy the supply of peanut butter from them that you want to last for an entire year, you would expect that you're getting a good price. But how do you know? Because you have to pay a huge amount of money for that giant jar of peanut butter. So how do you know you're getting a good deal? The way you know you're getting a good deal is by looking at what is called the unit rate. That is the only way to compare different quantities of the same product. So here we have a brand of peanut butter, and it comes in 3 different sizes. This size you can get at Publix. This size you can get at Publix. All 3 sizes you can get at Costco or one of those stores. So which one's the best buy? Which one is the best price for the product? So for argument's sake, we're going to call this small, medium, and large. So we're going to call this small, medium, and large. Now if I just compare the prices, this one's got the lowest price, so obviously that's the best deal. Because all I have to pay is $2.49. I don't want to pay $10.89 for peanut butter. But if that's what you're thinking, then you're missing the point, which is if you are going to use peanut butter for a long time, then you might be better off buying a larger quantity if it's worth it. And here's how you tell if it's worth it. You make a rate out of the information here. But here's the one little detail that you're going to have to remember starting today for the rest of your life. When you make a rate and there's money involved, listen here. When you make a rate and there's money involved, money always goes on top. In the previous example, I said that whatever came first went on top and whatever came second went on the bottom. So if you thought, if that's what you go by, this comes first, you would say that goes on top and that goes on the bottom. But now I'm giving you an addendum to the rule, an add-on to the rule. If there's money involved, money always goes on top. So that's what we're going to do. Here is our ratio. $2.49 for 12 ounces. The medium is $5.30 for 40 ounces. And the large is $10.89 for 80 ounces. And we can then compare them by finding their unit rate. And I just taught you how to find the unit rate. We use the same skill we've been using since the first week of school. Top divided by bottom. So we're going to divide up the labor. So everyone in these two columns of desks, you are in charge of the small. You must find the unit rate for the small. Everyone in these two columns, you are in charge of the medium. Everyone in these two columns, you are in charge of the large. You've got 30 seconds to find the unit rate. And we're going to go to 4 decimal places. 4 decimal places. All right, so what's the unit rate for the small? What did you get? We'll start with Aaron and then Chris. What did you get? Okay, well that's 3 decimal places. It came out to exactly 208. Came out to $2,075. $2,075?
No.
Okay, but that's you need to pick a way that makes sense. You're not saying things correctly. So stop trying to say the word for now, and just say what you really are supposed to be saying. Here, I'll help you out. 0 point. It's not 2075. 0.2075. Because you say 2075 and people think you mean 2075. It's not 2075. $2,075 per ounce. That's the unit rate for the small. For the medium, Dalia, what'd you get? 0 point. Okay, but again, I said 4 decimal places. It came out to exactly that? Yeah, it came out to 0.1325, and that's $ per ounce. And what about the large? What did we get? India and then Brianna. India. 0 point. Did you get the same thing, Brianna?
Yes.
0.1361 per ounce. So which one is the cheapest? Which one is the best buy? Aliana, which one do you think is the best buy? You think the medium. Benjamin, which one do you think is the best buy? Why? Why is the medium the best buy? I started out by saying the larger the size, the better buy it is. How come the large one's not the best buy? Yeah, it's less, but where? How do I know it's less? Because I see a 1 and a 1, and I see a 3 and a 3. So it looks like they're both 13 cents. Speak a little louder because nobody can hear. Okay, so then you look one place value over, and now there's a 2, and that one's a 6. And that is how you compare the decimals. So Benjamin is correct that the medium is the best buy. Comments or questions? All right, checkpoint number 3. You do not have to copy the question. You need to tell me which container costs the least per ounce. You got 3 minutes. People still finishing up. Go ahead and take 30 seconds to finish. All right, so let's see what we got. Which container costs the least per ounce? Start with Shannon, Taylor, Aaron, and India. Shannon, what do you get? Okay. Okay. Seems to be overwhelming support for 64 ounces. Christian, Deandra, and then Alex, and then Kiara. 64 ounces? 64 ounces. The correct answer is 96 ounces. So the 16 and the 32 ounce are definitely not the one. So let's do the 64 ounce. What's the unit rate for the 64 ounce? What did you get as the unit rate? Aaron? 0.04 for the 64 ounce. The unit rate was 0.04 per ounce. What about the 96 ounce? What was the unit rate that came out for that? Yasmin? 0.035 per ounce. Give me a thumbs up if you got those two numbers as your unit rates. So put your thumbs down. So all of my students who said the 64 ounce put their thumbs up. So that means you don't understand decimals. So this is a serious issue that if you walk out of my room, then you're not ready to be even a semi-adult if you don't understand this. This is 0.04. That's 4 cents. What is this? Is that 35 cents? Is that 35 something? I mean, that's the issue, is that you're viewing that as 35. That's not 35. What is it, Kayla? Well, it's you got the right idea. You kind of said a little too much. So let me. How much money is that?
3 cents.
That's 3 cents, right? So what does this decimal place represent? If that's 3 cents, then what is that?
35 cents.
That is not 35 cents. And if you walk out of my room saying that that's 35 cents, then we have a serious, serious problem.
0.0.
Okay? That's not 35 cents. Guys, listen to me and listen carefully. Again, you cannot walk out of this room thinking what you just thought. That's not how decimals work. That's how whole numbers work. But decimals are not the same thing. So I heard someone mutter it, and you don't even realize that you said the right answer. That is half of a cent. Every decimal place means a fraction of the decimal place that came before it. So that's 3 cents. That is a portion of a cent. Every decimal place is a smaller fraction of the place that came before it. So this is 3.5 cents. That's 3.5 cents. That's what it means. You don't read decimals, and that's why when Aaron said before, he said the decimal, he said, oh yeah, it's 2047 or something like that. That's not 2047. That's not the way numbers work. And you cannot walk out of my room thinking that. If you do, you have a serious problem because you won't be able to get a job doing anything. Anything. I'm saying anything. You can't work at a gas station if you think that that was 35 cents. You can't bag groceries at Publix if you think that that's 35 cents. Because they expect a basic understanding of math for you to be able to do any job. That is not 35 cents. That's 3 cents and half of another cent. So it's going to take you some time to digest this, and it's going to take you time to get a deeper understanding. And that's why you're 13 years old, sitting in a middle school classroom, and not already trying to find a job. But you are eligible to get a job in 2 years. So if 2 years from now you still think that that's 35 cents, that is a humongous problem. So the reason that the 96-ounce jar is a better deal is because this is less money. Here's another way to compare decimals. You stack them up. So this is 0.04. This is 0.035. But there's a number missing here. What should I put in this little place right there? Dalia? A 0. Now look at it. Now which one is smaller? That's not a 4, that's now a 40, and yeah, if you want to call that 35, fine, that's 40 and that's 35. So relating them to each other, you have to put the same number of place values for it to make sense. Okay? Decimals get stacked up to compare them. So, unfortunately, a lot of us got this wrong when you shouldn't have. But now, next time, you will not get it wrong. All right, so because of time constraints, you will get a free point for classwork.